Hello and welcome to today's Wolfram Institute live stream. Today we are having office hours with Daniel Van Zant. Uh, Dan is a PhD student studying theoretical and computational neuroscience at Florida Atlantic University, member of the Machine Perception and Cognitive Robotics Laboratory there. And he just recently joined the Wolfram Institute as an affiliate researcher, and we're happy to have him. Today, Dan will be giving an overview of his DeSci initiative, a project funded by members of the ResearchHub community titled A New Kind of Science Organization. Dan, why don't you, go ahead and tell us all about your project.
Absolutely. So I've been working on this project for the past little bit. I'm extremely excited about it. The key research question that I'm trying to answer is it possible for decentralized science to fill some funding gaps that are left by the conventional funding system? And if it is possible, what does that look like? And then I'm also investigating kind of scientific funding generally and trying to see where the funding gaps are and how we might fill them. So without further ado, I'll get straight into things. I'm going to have quite a bit of background up front here because I've done quite a bit of background on this. Here we go. So when we say, science is underfunded, that's kind of a vague thing. There's lots and lots of science that humans can do. Not all of it is particularly useful. There's lots of science that is probably not worth funding when other things are present. And so when I talk about science being underfunded or certain types of science being underfunded, what I mean is what I call transformative science. And so transformative science is any research and development that leads to what Wikipedia here calls historic inventions on their timeline of historic inventions, essentially something that got developed that completely changed the world when it got developed. So I have 5 on my list that I'm looking at: large language models, mRNA vaccines, smartphones/personal computing, genetic testing, and the World Wide Web. So it would be hard for anyone to argue that these things haven't changed the world in a meaningful way. And I would say that if it is true that these have all transformed the world in a meaningful way, then it would stand to reason that any research and development that led to the invention of these things would also be considered sort of transformative, important research and development. By the way, I can't see anyone, but if anyone wants to speak up and interrupt me at any time, they're welcome to do so. I like to answer questions and stuff during. So you might say, Daniel, this is great if you're looking at things historically. You can say, well, this particular piece of research and development led to this important invention. But how can you look at the research that is going on currently and decide whether or not it's important research? And the answer is, I'm not doing that. Essentially, what I'm doing and what I'm about to show here is I looked at these 5 transformative inventions. I looked at the research and development path that led to them. And then I looked at what the shape is of the research that led to them that was underfunded, where lack of funding really stalled the progress of the research in a huge way. And so essentially, I'm looking at what were the reasons that these things lacked funding. And if DeSci is going to solve science funding in a huge way, I think it needs to solve some of these root causes. And then sort of the counterfactual that I'm interested in is, if DeSci existed, whatever, 75 years ago, would we have developed all of these technologies 15 years sooner or something like that?
That's interesting that you say that these were underfunded or that there might have been a lack of funding. I mean, forgive my ignorance, but like, the World Wide Web, that was like the .com uh, boom and bust kind of thing. So there was a lot of investment, at least in Silicon Valley, for that, and and the large language models. There's huge, huge investment going on there as well.
Yeah, so that's a really good point, Dugan. When I say underfunded, I mean that there were periods, very long periods of underfunding.
Mm.
And so for the world, because these are all transformative now, all of these inventions and the research and development that continues to go into them is pretty well funded because everybody recognizes that these things are important. But all of these have had periods in the past 75 years where the research and development that led to the technology kind of languished for at least like 10 years or so because of lack of funding somewhere in that dependency chain. And so, yeah, that's what I really mean. I don't mean that these things are underfunded now. I mean that there were historical periods where the research and development that led to them was underfunded.
Okay.
And speaking of dependency chains, I'm not really going to go through all this. It would take way too long to read. But if anyone knows what a dependency chain is, essentially it means that every piece of science and every piece of technology requires other pieces of science and pieces of knowledge and pieces of technology to exist. And this is a great big dependency chain for a whole lot of inventions, including going into the future, which I think is kind of cool. But really what it illustrates is that for everything that gets developed, so for all 5 of these inventions, there was a very, very long chain of science and technology that had to get invented first. And for quite a bit of the science and technology, it was somewhat non-obvious that it would end up leading to these very important inventions. Which is, I guess if it was obvious that it was going to lead to an important invention, there wouldn't have been periods of underfunding. And so this is also sort of defining terms a little bit. When I talk about underfunding, what do I mean? So a good thought experiment that I like to use to illustrate this is if all of the world's governments and all of the scientific institutions and everyone in the finance world and basically the entire world decided to pool all of their resources and try to solve Alzheimer's, we still wouldn't solve Alzheimer's tomorrow. And the reason is because very quickly, as they pour more and more of those resources into that research, they would reach a point of diminishing returns where, well, there's only so much equipment that we can use to research Alzheimer's that exists in the world. There's only so many people that are qualified to research this. There's only so many institutes or buildings to do it in. And so what I'm talking about when I talk about underfunding is the point before we reach that point, the point where you can throw more money at an area of research and accelerate the speed at which that area of research is moving. And so, for instance, right now in artificial intelligence, I would say artificial intelligence has all of the funding it can possibly handle. I don't think you can throw a lot more money at it and really increase the speed of artificial intelligence research. All of the relevant people are going as fast as they can, and all of the relevant people are throwing as much money at it as they can. And so the last kind of background is we can talk about the dependency chain, and theoretically we could trace the dependency chain all the way back to Francis Bacon and him coming up with the ideas behind science, or we could trace it all the way back to Aristotle or all sorts of other things. But I think it makes sense to trace it back to the most recent phase transition in science funding. And so we can say, okay, science funding this year, the landscape of it is more or less like the landscape of science funding last year, is more or less like the landscape of science funding the year before. How far back does that go? And so what was the last major transformation that happened in science funding? Kind of the conclusion that I came to from my historical research, that actually when I talked to Stephen about it, he agreed with from his historical research, which was very gratifying, was that the last major phase transition to science funding ended in 1950. So some of the history behind this, a huge amount of resources were spun up during World War II to do all sorts of different research and development. And then World War II was in some sense won by research and development. It was sort of won by new technology. And so after World War II, all of the world powers were like, okay, research and development is really important. So all of these different institutions and funding that we've spun up temporarily for World War II, let's solidify into civilian funding and grant mechanisms. And so I'm just going to go through this really quick, but there's this huge list of stuff that happens in the 6 years between 1944 and 1950. In the USSR, the Academy of Medical Sciences was founded. The primary French Research Institute was sort of reinstituted after a funding gap. The NIH took on the grants program that before exclusively belonged to the National Cancer Institute. And this is the academic grants program that we know today. The Office of Naval Research was established, and it was the first military organization to fund civilian research. The scope of the Medical Research Council in the UK increased significantly. The scope of the University Grants Committee in the UK increased significantly. The first science town was founded in the USSR. And there's a whole rabbit hole I could go down that I've figured out about these science towns. Essentially, Russia has a completely different way of doing research and development, and has for the past 75 years or so. And it's very secretive and very interesting. But then in 1948, the founding of the National Research Development Corporation in the UK happened. And then in 1950, the National Science Foundation was founded. So before World War II, there wasn't a very large sort of public funding mechanism for science to speak of. The commercial mechanisms for funding research and development has been around for probably at least hundreds of years. You know, if something's going to be obviously profitable, you fund it. But the system we have today with the NIH and the NSF and their equivalents in all these other countries, this was mostly all established between 1944 and 1950. So when I'm looking at these dependency chains, 1950 is sort of the starting date. So I'm saying from 1950 to now, how has this technology developed? What were the periods that it was underfunded in? And so I'm using 3 research methods. The first is this massive historical analysis that I did, and that's finished. I ended up having 60 plus different historical sources that I use for this thing, and I'm working on writing it up. It's a monster. The second is something I've started and I'm currently engaging in. And this is taking this historical research that I did, where I sort of figured out what the root causes were, and I figured out what periods of science were underfunded, and talking to a bunch of experts, both in decentralized science, but also people like senior scientists and directors of research institutes. And just kind of saying, hey, here's the major problems that decentralized science has to solve if it's going to succeed. Has decentralized science solved any of these problems in any meaningful way? Do you see any theoretical solutions that could solve any of these problems? These kinds of questions. And then finally, from the information I get from these experts, I'm working on doing some of what I call computational foundations of science funding. And so I'll get into that in a little bit, but essentially, I think science funding is something like a meta heuristic search algorithm over a fitness landscape. And so, and there's really good tools to investigate that type of thing, and it's very cellular automata-esque. And so I'm interested in figuring out ways to simulate the current system within this paradigm, and then ways to simulate the potential solutions within this paradigm and see what sort of happens at the higher level computationally. And that third thing is something that I've just barely begun. And so this is finished, this is underway, and this I'm just starting out on the third thing. So as far as root causes go, the first thing to talk about before we talk about any of that is that there is definitely a shape to the research that is consistently underfunded. And the shape of that research is high risk, high reward research. And so I have these 2 curves. You can think of low risk, low reward research as sort of fitting a normality curve. So most of the time you say this is going to be moderately valuable. Most of the time it is moderately valuable. You put money into it, it's moderately valuable. You move on with your life. Great example was lipid nanoparticles. essentially everyone knew that this research was going to be useful. And so a bunch of people all worked on it together. It got lots of funding, and we developed really great lipid nanoparticles, which ended up being really important for mRNA therapeutics. And so it was low risk, low reward. It got funding. Lots of people worked on it. And we finished that sort of stage of the dependency chain in about 2 years. Example that is of a high risk, high reward system would be the initial development of mRNA therapeutics. It took around 15 years, from around 1990 to 2005. Many grant applications were denied. It was just this one researcher named Catalin Carrico, and she actually got demoted at her university because she continued to work on this against her department's wishes, and she almost got fired a bunch of times. And all of us should be very thankful to this scientist, because she is the reason that it's very possible that she's the reason that COVID isn't still floating around today. And it is still floating around, but it's not floating around at the same volume today. And we were able to develop a vaccine for it. And an interesting counterfactual that I like to think of here is, if she was able to get funded and this time period was much shorter than 15 years, then COVID might have been much less deadly. We might have had maybe lockdown for like a month or two, but then mRNA vaccines already existed and we already used them for flus and stuff because the development of them happened earlier. And we developed mRNA vaccines for COVID very quickly. And, we had a month or two of lockdown, and it's still a crazy pandemic, but it's not sort of the 2 years of lockdown that we ended up having. And so there's several different root causes of high risk, high reward research being underfunded that I'd like to talk about. The first is that peer review reinforces orthodoxy. And so this is a cute little guy. He's a black 6 mouse. He is the current model organism for the vast majority of biomedical research. And he is also by far the most popular model organism for biomedical research, even when there's a better organism for the particular bit of research that someone is doing, and they can sort of illustrate that with some sort of empirical or theoretical support. And so this is a large problem. Lots of things about the black 6 mice don't translate to humans, depending on what kind of disease you're studying. There's lots of better model organisms you could use. But essentially, there's this self-reinforcing loop or attractor where junior scientists are excited and they apply to grants with different model organisms. So someone says, I want to use a zebrafish. Someone says, I want to use an axolotl because I think it would be best for studying this disease for these reasons. They only receive funding for black 6 experiments on this little guy here. Those junior scientists become senior scientists, and then these senior scientists are epistemologically humble, and they only feel comfortable vetting grants that use black 6 because that's the only organism that they have personal knowledge and experience with. And so then the next generation of junior scientists only gets grants to work with black 6 mice, and the cycle continues. And it's sort of a random, it means that a lot of science sort of ends up getting into a random genetic drift where certain choices are made at some point for some reason, but then it becomes orthodoxy and then it becomes entrenched. And there's just no getting away from it, even if it's very unhelpful. And so when I've been talking to decentralized science experts, there's some kind of obvious solutions to this, which is that in many ways, experts aren't the ones approving or disapproving decentralized science grants. And so here's what this might look like with decentralized science. Maybe we have the current system.
Backing up just a little bit. So it's the senior scientists which are approving grants at this current stage. Is that right?
Yes, and even if it's commercial research, it's still senior engineers that are approving what the company funding goes to. And they're also epistemologically humble and don't feel comfortable spending lots of the company's money on something they're less familiar with. So the same thing also applies in commercial research.
So they get grant funding to what they field that they know to be reliably beneficial, fruitful, I guess. So there's less
Yes,
risk taking.
yeah, exactly. They give funding, whether it's commercial or public funding. They give funding to what they have personal knowledge of. Because if a senior scientist has never worked with a zebrafinch before and he sees a proposal using zebrafinches as a model organism come across their desk, uh, they might say, okay, well, I don't really know anything about zebra finches, and there's lots of other proposals here where I know the money would be money well spent and we would have some kind of results. And so I'm just going to kind of put this one off to the side and not fund this one. So it's not, I've heard a lot of people talk about this effect as kind of a malicious thing, but when I was doing my historical research and when I've been talking to people about this, it doesn't seem particularly malicious. It just seems like experts in their field are epistemologically humble and they don't want to speak to or give other people's money to things that they don't know much about. But you end up with these weird attractors because of that, kind of unintentionally.
Yeah, yeah, it's very human bias.
Yeah, yeah, it's absolutely very human bias. So yeah, I don't think senior scientists or grant writers or the NIH is super malicious in any of this. It's just sort of a thing that happens naturally if you have this kind of system. And so this is, of the things I'm going to talk about, this is the only one that I would say that the decentralized science world has illustrated firmly that they're able to do. The rest, they're sort of theoretical or early efforts. Uh, but decentralized science is only around 4 years old, so it's understandable. But I don't feel like they've managed to really prove that they can solve these issues. But this issue, there actually is a lot of proof of decentralized science organizations solving it. Here's an example with the model organisms that I was talking about. So let's say we have the system now. Senior scientists only feel comfortable vetting grants that use Black 6 mice. Junior scientists apply to grants with different model organisms. The same thing happens now when it comes to the public funding or commercial funding. The junior scientists only receive funding for Black 6 experiments, but there's also this secondary funding mechanism from decentralized science, decentralized autonomous organizations, and the junior scientists are able to receive funding for their other experiments from these sorts of new kinds of science organizations. And then this last part hasn't been proven, but I suspect this is how it'll go. Those junior scientists become senior scientists. Uh, those junior scientists end up applying for grants with different organisms. Whatever the next generation is, they receive public funding and Dow grants from multiple organisms because now there's a crop of senior scientists that are familiar with a variety of model organisms. And you can see how Dow's existing sort of managed to snap science funding. And at the bottom there is the Black 6 mice with his other more unconventional model organism friends, the zebrafinch and the axolotl, and I think the killifish it's called. Give me just 1 second. My computer just told me it's about to run out of battery. I'm having a bad time today with computers.
Get power flowing.
All right.
Uh-huh.
Perfect. And then I actually have a nice little computational simulation of this. This is sort of the first bit of the computational foundations of science funding that I've done. And I can show that right here. Here, give me 1 second. Let me just stop screen sharing. Apparently it wants to reload the page. All right. perfect. 1 second. I'm so sorry about this.
No worries, you're good.
For anyone watching the video that didn't see things before, my computer started having issues with me about 5 minutes before this started, and that's where some of the technical difficulties are coming from. I apologize.
Oh, while we wait for your computer, you had mentioned in a previous meeting that it might be a good idea to, I don't know if you're going to get to this soon, but to have less senior researchers uh, be in the loop for grant allocation.
Yeah, so there's some interesting research from the peer review that's done in these decentralized communities, uh, and some of the grant review as well, that the ideal peer reviewer and grant reviewer might be someone who's at the level of like a professor in the first 5 years of their career. So they have the full knowledge of their field, but they're not sort of entrenched within the orthodoxy of their field yet. And I'm just saying this based on the grants that end up being successful and who really pushes for those. And I mean successful in sort of utility to the world. Uh, and I'm also saying it because of, sorry, I'm also saying it because of the peer review that ends up being voted as being very successful and very helpful. So I've got this animation up. Let me share my screen real quick here.
Okay.
Come on now. All right, share that. Perfect. Oh, you're kidding me. All right. Well, we're not worrying about the animation. I just decided to reload the page because I went to Zoom and wanted to share my screen again. Um, essentially, though, what I was able to show, and I'll just explain it a little bit, uh, is that you can create systems with two types of dynamics. You can create one type of system that works like the peer review system, where it's looking for things that are valuable, but only if we have lots of information that they're valuable. So what it's doing is it's uh, exploring kind of a cellular space, and it's estimating the value of each cell based on the value of its neighbors. So if a cell has lots of neighbors that are already discovered, uh, then the peer review algorithm says, okay, if it has lots of neighbors that are already discovered and it's valuable, then I am interested in exploring that cell next, and then it continues on that way.
I'm not sure
And
if
then
we're
you have
seeing
more
what
of
you're
the
looking at.
decentralized science cell. And in the decentralized science, uh, I'm just explaining it a little bit. I yeah, I'm having very many technical difficulties with the computational simulation, but the uh, the decentralized science cell has different dynamics. And one of the interesting things that I found from this computational exploration is one, uh, you end up having academic subjects emerge very naturally from the peer review system because you end up with sort of balls that are separated and don't really connect with each other. But two, the optimal system is actually a combination of both systems where it alternates between choosing the next cell the peer review way and choosing the next cell the decentralized autonomous organization way. So I thought this was very interesting because I think it's some indication that maybe there isn't a right system. Maybe peer review isn't the right system in some sense. Maybe decentralized science isn't the right system, but maybe it makes sense to have both of these as complementary systems.
Um, can you share the link? We're seeing the slideshow with the axolotl on it.
Yeah,
If you give me the link, I
um
might be able to, if it's possible, to share it on my end.
yeah. Um okay, yeah, I can do that real quick. let's see here. It is really not cooperating with me. I'll see if I can grab like a video later and share it in the chat or
That'd be
something.
fine.
But I'd like to, yeah, I'd like to move into the rest of this, and this is being extremely uncooperative with me, unfortunately.
Okay.
Yeah, I think for those people that are following along, we are having updates on our Discord server quite regularly. Dan is doing office hours, I think, weekly. So for those that are really interested in this part, Dan will definitely have that available if you join the Discord and follow the conversation there.
Yeah, absolutely. I'm doing them every 2 weeks. And Dugan, do you think you could actually post the link to the Discord in the YouTube chat just at any point here while I'm talking?
Yeah, that'd be no problem.
Awesome. Thank you. Okay, yeah, I'm very sorry about all the technical difficulties. I'm using a computer that's very old and very slow because the other one wasn't working, and so having many difficulties. All right, so the second root cause is that specialized resources are concentrated in sort of elite institutions and companies. And so, what I mean by this is electron microscopes are a little bit more common now, but for a while there, only a few universities and companies had electron microscopes. And the electron microscope was sitting there idle a lot of the time. Uh, and there were researchers who were interested in using it that would have even paid to use it, but because they weren't associated with those universities or companies, they weren't able to. There's a great example in the development of machine learning and large language models where for a long time, machine learning researchers had a very hard time getting a hold of GPUs, even though there were companies that had a lot of them, and there were people doing crypto mining and things like that that had a lot of them. And here is Jeffrey Hinton, who's considered the godfather of artificial intelligence, talking about how he sent an email asking NVIDIA if they could send him a single free GPU card. They said no. These two GPU cards cost under $1,000 collectively, and they were the start of the deep learning revolution. And sort of, at least what some of the people that worked on this say is that the researchers basically had to go out and buy these on their own budget at the computer store. I experienced my lab sort of has a story about this, and my advisor has a story about this, where in the early days of machine learning, the university wasn't approving budget for GPU cards, and they weren't allowing him. And he tried to access sort of high performance computing clusters at other universities. And they said, you aren't associated with us. You can't use this. And he had to actually get into the university budget and make like some FOIA requests and make the case to the department heads where he was like, look, a GPU costs less than a mouse for 3 months. Please let me buy some GPUs. And that's how the lab ended up getting started.
That's crazy.
Yeah. and what's really crazy is that other places had GPUs that he could have used, giant clusters, and for some amount of time the GPUs were sitting idle and he was willing to pay for it, but because the association wasn't there, nothing could be done. And so decentralized science has something that exists now and something that I've been talking about theoretically in the interviews. This exists now. It's quantum computing or neuromorphic computing as a service from this company called Dynex, where essentially you can send crypto and send a computing job, and it'll get run on someone else's neuromorphic or quantum computing cluster, and then the results will get sent back to you. So this is an example where anyone in any country, regardless of association, can decide, I want to do this kind of experiment with this kind of hardware, and they can just do it. And then there's some really interesting things that are still in the very early stages that are being worked on that are even more exciting. Things like robots that are able to execute certain kinds of very simple biotech experiments where you're just putting a pipette and a bunch of electrophoresis gel and seeing what happens, things like this. And there's people that are working on spinning these up such that you might have a little camera or something, and you can send some crypto and send whatever you would like the little electrophoresis robot to do, and it'll perform a biotech experiment for you. and send back the results. And so I think as artificial intelligence and robotics advances, and as this advances, there's the potential for this sort of specialized resources being concentrated in specific places issue to be solved in that way. And that if you have the money, you can just send the experiment and send the money, and someone who does have the equipment can basically perform the experiment for you.
That's really cool.
Yeah, there's some really exciting stuff going on with this. The next one that I don't actually know how decentralized science is going to solve, and I haven't received any answers that I'm super happy with out of interviews, and so I'm going to keep pestering people about it, is the preliminary data paradox. And so this essentially means that a company or public funding says, well, you're going to need some preliminary data before we're going to give you funding to pursue this, but the preliminary data requires funding, and you end up in sort of a catch-22. This is a different time that mRNA was significantly delayed, where this company called Transgene validated animal mRNA vaccines, and they were looking at doing human mRNA clinical trials, and they were getting things set up with the FDA, but they ended up deeming it too financially risky to spend $100 million on it. One of the main people who worked on this at Transgene has called that a $1 billion mistake, and they severely regret that. And then there was like a 15-year gap before the next group decided to take the risk and start human clinical mRNA trials. So this is another thing where COVID could have been solved much easier if these sort of underfunding issues didn't exist.
Yeah, that goes back to the sort of, it's new, we don't know if it will work, we're not going to fund it. Bias.
Yeah, exactly. And honestly, that's a hard problem to solve. I am not quite sure how you solve it, because somewhere you have to have somebody that just kind of makes a bet on faith with no empirical evidence that the thing is going to work, and they just do that. And so that's a hard thing to justify financially for anyone, whether you're decentralized science or public funding or private funding.
Is there an argument that with DeSci you can have more of a democratic vote as towards where the funding goes, and then that allows decision making to be more like a communal kind of opinion, which has some benefits? Because if it's like a hierarchical structure, maybe there's some key decision maker right at the top that's not exposed to what's happening on the ground. Whereas if it's community based, it's like people that notice that this is a institutional level issue can actually vote for science to be funded in a different direction.
Yeah, I think there is an argument to be made there. I guess, but I also think that decentralized science communities are also making sort of risk reward assessments, and that maybe in some cases they could fund things, but I think most of the time, and from a lot of the proposals I've looked at, decentralized science communities also want preliminary data before they fund things.
Yeah.
And so it's a tough issue to solve. I think one of the things that I haven't heard anyone connect this in interviews, so I wasn't going to bring it up, but since we're talking about it, one of the things that I've seen in sort of decentralized science that I think could solve this is reputation mechanisms, in terms of this person does very good science that ends up being very profitable. And then maybe instead of trusting the data, you trust the scientist. And if someone has a very good reputation and they've done lots of research that has had very good returns for the decentralized science organization, then you say, okay, we're going to trust them. We're going to bet on them. We're going to fund their study, even though there's no preliminary data for it. And maybe some of these like decentralized reputation mechanisms are a way to do it.
And then when you say profitable, are you talking about like actual revenue generation, or how would that compare to doing like basic science?
Yeah, I guess whatever the goals of the decentralized science community are, some of them are profitability, some of them are whether or not they're making progress on solving a particular problem. So maybe useful would be the better word. Just if someone has a reputation
sense.
for having very useful research ideas and research proposals, and you can prove that, maybe it makes sense to just kind of bet on the person as opposed to betting on the data or betting on the experiment. Yeah, that's one thought I've had. I'm trying to get some interviews with some of the decentralized science folks who are doing these sorts of decentralized reputation mechanisms to ask them what they think about this. But that's my early
Yeah,
thoughts
that'll
on
be
it.
great. And if anyone has ideas that they want to contribute as opinions about the space and how DeSci could potentially benefit science more broadly, again, yeah, just feel free to engage through the Discord, sign up for our newsletter, etc. on the website.
Yes, yes, please do. And I'm talking to lots and lots and lots of people. So if you engage on the Discord or any of that, uh, and you have a really good question that's worth asking, it's very probable that I'll be able to ask that question to someone who's going to be able to give a very thoughtful, good answer to it. And so the second to last sort of root cause is competitive fragmentation. This graph, like the dependency graph, I'm not really going to go through it, but this is the browser wars and all the different browsers and the browsers that split off from browsers. And every time you see parallel lines here, it means that different teams.
Can you share your screen?
Yeah, I thought I was. Did it stop sharing?
Yeah. It's maybe it's been 10 minutes. Oh boy. All right.
Oh
Go.
gosh. Okay, I thought I was sharing this whole time. Okay.
That's better.
All right, perfect. I'm trying to think. You guys saw this, right? Sort of Dynex paying for quantum computing type of thing.
No, we didn't see
I don't
that.
think we got you.
Oh gosh. Okay. Did you guys see this?
No.
Nope.
Oh my
Um,
god. Okay.
you
So I
you
think this
you
was
were
the
very
last.
you were very descriptive with your explanation, so it was easy to imagine what you were talking about.
Mm-hmm.
Good, good. All
Yeah,
right.
I
Well, I'm
remember
very sorry for all of the technical difficulties.
Hinton and the cards, GPUs.
Show us that
Okay.
competitive fragmentation graph. That was pretty interesting. Or are you still getting it? Yeah.
Yeah, so this is the browser wars, and this is sort of all the different browsers over time and what browsers split off from other browsers and the market share and stuff like that. And again, I'm not going to get into this because it's not really what the presentation is about. But the point I want to make is that every time you see parallel lines there, it means that very, very smart people were doing the same work over and over again and solving the same problems over and over again and just doing them in whatever way they could patent or turn into IP for their company. And so I think what you're seeing on the graph here, in my opinion, is an incredible waste of intellectual resources in terms of imagine all of the people that were working on all of these browsers and imagine if instead they had collaborated on one super browser or maybe a smaller team had collaborated on less browsers and the smart people had gone on to do other smart people things that help the world, things like that. And so this is competitive fragmentation. It just means that people compete with each other and don't want to share information and don't want to collaborate. And so they solve the same problems over and over and over again. And it happens in academia as well. Something I was noticing from doing the historical research, although it's not as obvious. In general, when it happens in academia, it's like Harvard competing with MIT. And so their labs don't share research with each other until they absolutely have to. And they publish the paper, things like this. Or different labs will be working in the same space and they'll sort of be the premier lab in their space. And so they'll be competing for grants and they won't share certain results with each other, things like this. And so in public and private funding, competitive fragmentation is a huge issue. And it means that we waste enormous amounts of time and enormous amounts of intellectual resources.
So it's duplicated effort as competition.
And what did you say?
It's like duplicated effort. in the form of competition?
Yes, it's duplicated effort. And because you have to pay all these people, it also means that for anything where there's competitive fragmentation, you have to pour much more funding into the system to do the same amount of research than you would otherwise. And so, yeah, it's just kind of a waste. It's very early days for this, but there are some interesting solutions for this in decentralized science that I talk to folks about. This is a graph from bonfires.ai. Essentially, the idea is you have an AI agent. The AI agent has access to some body of knowledge, and you worked hard to gather that body of knowledge, whatever it is. And so it's worth something to you. Let's say you have information on real estate in Miami that nobody else has, whatever it is. And sort of what they're working on is fully on chain. You can say, all right, you have to pay me 20 cents to ask my agent a question. And then either someone or that someone's agent can talk to your agent, and maybe you've given, and maybe it has a budget or you have a budget. So you're like, all right, yeah, that's fine. 20 cents. I need this information. Tell me about average home prices in this particular neighborhood in Miami. You send whatever crypto on chain. The agent sends you the answer, also on chain, or maybe not on chain. So it's not just broadcast out there for everyone, but the agent still confirms that it sent you the answer. And the idea is that people can collaborate and people can share information while still being compensated for the intellectual property that they worked hard to generate. And so this is very, very early days, very, very theoretical. But like I said, DeSci is 4 years old. And so a lot of things are early days and theoretical. But I do think it's a very interesting solution to this problem of competitive fragmentation, where if I'm Microsoft, maybe I can just send, some amount of money to Apple to learn the information they have. Apple gets compensated for the information they work hard to generate, and I get information I need to keep moving forward. And then the last thing is, and I didn't put this on here because I'm very much in the process of exploring this question, but a lot of decentralized science organizations have pointed out that they have issues attracting top talent, and that a lot of the top talent is concentrated in academia or elite companies, things like this. And I haven't been super happy with the answers I've received from interviews. They haven't been super substantive as to how you handle this question, but lots of people have agreed that it's an important and hard issue and it affects decentralized science in a big way. And so on Friday, I've got a meeting with 2 directors of sort of more conventional university research institutes. And I am going to talk to them about decentralized science and how they would look at it if they were picking out funding for their institute and how they would think about it. And maybe that'll give me some insight as to more detail on the problem and more about the potential solution.
That'll be very interesting.
So yeah, that's
get
it.
Their opinions.
Yeah, I'm excited about it. So so that took a lot of time, but I have done a lot of research. And so I'd be happy to answer any questions or answer any thoughts people might have or anything like that.
Maybe for audience members who are new to this concept, can you talk, define DeSci, what it actually is and what the promise of it is, just for absolute newbies?
Yes. So the mechanisms of DeSci are somewhat complex, but the idea is relatively basic. It's that if I care about a certain type of research, let's say I care about, I don't know, Parkinson's research, and I have $20, because of current financial regulations, there's not a lot of great ways for me to dedicate that $20 towards Parkinson's research efficiently. I can give it to a charity, but there's all sorts of inefficiencies there. And maybe I don't like the specific projects the charity is funding. And so what decentralized science allows people to do is it creates a new kind of science funding organization where I can give $20 towards that organization, and that $20 gives me some amount of voting power. And then the organization has a much larger pot of money, and ideally it has ways to generate even more money from the research that it funds. And then giving that $20 gives me the ability to vote on what the organization's research priorities are pretty much indefinitely, even if the amount of voting power becomes smaller. And so it's a way for people who are interested in science and have money they would like to dedicate towards science, but don't have $1 million to open their own charity, to kind of pool a lot of that money together and fund lots of cool science. And there's lots of other cool things in decentralized research, like you can pay people for peer review more easily and all sorts of other things. But I would say the primary way that decentralized science is currently used is that kind of funding mechanism where a bunch of people all pool their money together and then they all vote together on what projects it goes to.
So in that sense, there can be more tolerance for risk taking, unconventional research methods.
Yeah, and I think that's because a lot of people in decentralized science are involved, have given money to whatever organization because they're just really, really excited about seeing a problem solved. And so there's hair dow is a really great example. Baldness is a very large issue. Lots of people would like to not be bald. There's almost no research into curing baldness. But all of these people decided to pool their money together and start hair dow. And now hair dow is funding some really exciting research that might help cure or prevent baldness. And so, yeah.
Definitely in favor of that one.
Yeah, I think many, many people are. Hair dow is actually doing some really exciting work. I was looking into it. I think there's a decent chance that we have some sort of substantive cure for baldness in the next 15 years. I was looking into the research. And so that'll be exciting if that happens.
Awesome. I know Brian Silverman on the call here has a lot of thoughts around this space in general. I wanted to open the mic to see if you wanted to comment on what was presented here today.
No, actually, the last couple of discussions we had, I thought were pretty interesting and productive. Nothing new to add at this point.
I was going to say,
Yep.
Brian has been one of the primary contributors to a lot of the thought and a lot of the research direction behind this so far. He's been extremely helpful. He's been showing up to the office hours. Thank you, Brian.
Awesome. Okay, cool. Yeah, I think that answered all the questions. And
Do you want to mention
yeah, I look forward to
the upcoming SciCon?
Yeah, I think people can still request to join. It's kind of like something that ResearchHub put together. So, by the way, the funding for this science research that we're doing, which is kind of like meta science, I guess, was sponsored through donations on the ResearchHub platform. So, shout out to ResearchHub and ResearchHub Foundation for making that possible. And it's an example of how DeSci can work. You know, it's like it's DeSci, but it's kind of it's built on this idea that there are these research coins, and you can allocate research coins to whatever funding you want. And it was motivated by an article that Brian Armstrong wrote a while ago from Coinbase. So I think there's ideas from the crypto space about why this decentralized approach works for finance and economics, and how potentially there's a way that that can help with science funding as well. So this is like very early days. It's kind of exciting to see how some of the stuff materializes, and we just thought that it makes sense as a research institute that is trying to innovate how to do science and not just do the innovative science, but to actually reimagine what an institute that does science can look like. I just thought it would be a great idea to actually investigate that as an actual like scientific effort. So yeah, that's ResearchHub's SciCon event happening Thursday. So if you check out the website, they have a Luma, and I'll be there. So if anyone wants to say hello in San Francisco, yeah, I'll be there this week. And Dan will be there too.
Yeah, absolutely. And so, yeah, I'm super excited about this. I was somewhat surprised that I was able to get funded for such a crazy idea, because there's no way I would ever get funding from this anywhere else. And I think it is valuable to sort of investigate the apparatus of science funding in this way and see where the gaps are and what the root issues are. Yeah, I've enjoyed getting to talk to a lot of people in this space and getting more involved with this world.
Right.
Awesome.
And so I'm excited for you to go to this convention, San Francisco ResearchHub SciCon, and for you, you've been doing interviews with people in this space and people adjacent to this, and I think you'll have a lot to talk about with the people who are going to that convention. So excited for that.
Yeah, I'm excited.
Comes out of that.
By the way, Dugan, I've got a couple of videos of the interviews where people have given me, they've been like, I don't care, post it online, whatever. So if we want to post those on the Wolfram YouTube channel, we can do that.
Okay. Yeah, we might start a little playlist for this DeSci effort. Post those to that. That'd be great.
Yeah. And so, yeah, I've had two people who are very generous. And one of them is James Sinka, who's the founder of BioProtocol, which is huge in this space. So that would be a really cool interview to put up.
Yeah.
And the other is Joshua from DeSci World. So actually both people who gave me permission to do that were people whose interviews I think we'd really want to put up.
Cool.
Awesome. All right. Well, James, are you going to SciCon, or is it?
Yeah, I'm going to be there. Yeah.
Oh, awesome.
Stephen
Okay.
Wolfram will be there as well. So he'll be in town. Yeah.
All right. Well, I will see you there. And it was really wonderful getting to talk to everyone about this.
Exciting stuff.
Great. Okay.
Thank you so much, Dan.
Chat again
All right.
soon.
Have a good one. Bye.